Hello, my name is Bryant Harrison, and this is my glider video report. To start with, we were assigned the task of constructing a glider. I have named my glider Mach 2023. The requirements for our glider were that the glider must fit within a 16-inch by 16-inch square. It must be hand-thrown. It must be made primarily of balsa wood. The balsa wood is provided for us, and the glider is required to go a distance of 20 feet through the air. Now here is my design process. I went through the process of collecting sources in order to piece together information to help me build my glider. To start with, wing shape. So I found that tapering creates extra lift. Now that gave me three options. What I could do is I could create a trapezoidal shape, an oval shape, or a swept back shape. I went with the trapezoidal because of the ease of construction. It would be very difficult to cut into swept back wings and keep them attached, and it made the trapezoidal wings easy, and it made the calculations of the area of the wing much easier. Now was the decision on where to place the wing along the fuselage. Now it could either be placed in the nose, middle, or the back, and from my research, further forward along the fuselage pulls the center of gravity forward along the fuselage, which then creates more effect with the lift. Now there was an option of adding dihedral to the wing. This scale is typically good for about 3 to 5 degrees, but I decided ultimately that it was not worth adding dihedral because it would make it very difficult to construct without potentially ruining the wing because it was split in half. The reason I added tail is because it counteracts changes in the lift in the main wing. But gliders often have a T-tail, which you can see right here. It would get the same effect with a traditional tail wing. Now, the shape doesn't really matter at this scale. I decided on a tapered wing to sort of match the main wing and size it to be about 1/4. Now, overall sizing, the first thing I started with was that the wingspan would be 22.5 inches. And I did that because it has to fit in the glider itself has to fit in a 16 by 16 square. So if you take the main diagonal, which is found to be 16 times square root 2, you get about 22.627. And so round that to 22.5. So then I made the fuselage 16 inches, which I found a good ratio is about 75% of the main wing. Then I estimated the size of the tail to be good around 5.5 inches. I estimated that the 4 inches back for the wing placement on the fuselage would be a good spot. I used an aspect ratio of about 7 to estimate the root and tip chords, which the root I found to be about 5 inches and the tip to be about 1 inch. So here's the submission for checkpoint 1 where we had to design our glider. And as you can see, there are my drawings and my measurements for the glider. Then is checkpoint 2. And here I created a glider out of cardboard using the dimensions that I designed in checkpoint 1. Then I realized a lot of those measurements wouldn't work. So I cut down on the wing size because I realized that the width of what we were given was only 3 inches, so it couldn't have been a 5-inch root cord. And so I had to adjust that accordingly. I shortened the tip cord, realized that the fuselage also would not be that thick. And then I realized that the tail was a little too big and that reducing it reduced a lot of weight on the tail end of the glider. I also realized that when it comes to throwing it, a small angle of attack is much better than a large one. It was time to actually construct. At this point, I started to make the wing, and I realized that I would need to cut some off of the wing planform to create the tail wing. I used an X-Acto knife to cut through the balsa wood and get my wings. I used a scroll saw to cut the fuselage and used a belt sander and sandpaper to sand it all down. I used hot glue and super glue to put the wing on. Then I realized after construction, I had to shorten the fuselage to fit it within a 16 by 16 square. Then I realized the center of gravity was way too far back. So I added Play-Doh to the tip of the nose, which pulled the center of gravity forward. And this X on this picture here marks the spot of the center of gravity and is actually closer to the 3/4 chord, which is not ideal, but it was the best I could do given how the dimensions of my glider. So now it's time for the flight.
Yeah.
That's good. So as you can see, it made its 20 feet, and so it got to where it needed to go. But if we look at it, it was released really high, which was not already a good sign. And then it immediately turns and it flips around and barrel rolls to the ground. Now, what this means is that the wings were imbalanced. And this is due to the fact that whenever I glued the wings on, they ended up being at sort of a diagonal instead of straight on, which definitely was not ideal. And so the glider achieves exactly 20 feet. Here's a picture of it fitting within a 16 by 16 square, where the tape measure is 16 inches. Now, if we overlay a protractor on that one seam where I released, you can see that it's almost about a 53-degree angle of attack, which is really high. A really low angle of attack is so much better, and we can show mathematically that this is not ideal. We get 11.624 for our coefficient of lift. Then the total coefficient of drag, 9.190, which those are very close numbers, which means that there's a lot of drag and not that much lift, which is why the glider only went 20 feet. So to conclude, I think overall this is a very successful project. I accomplished all that I needed to do in my glider. I also learned valuable ideas about aerospace, particularly gliders, and the sense that how they work, how to design them. I also had a lot of fun launching the glider. It was pretty cool seeing everyone's designs. Now, if I had a chance to redo this project, I'd size down the glider as a whole. I think a lot of the problem was that it was weighted a little too much overall, so it didn't fly very far. I would have also placed the wings further back, which would also cause the center of lift to come further back, which would make it easier to drag the center of gravity forward to put it more at the quarter chord length, which is where it was the ideal spot to create the most amount of lift. I also would have made the tail wing a little more proportional to the main wing. It looks a little small on the final design, so I think making it a little bigger relatively to the wing would be ideal. And here is my sources. Thank you for listening.